Hey guys, in this specific video we'll be talking about the white paper of Uniswap which was released 2 years ago. It was written by Hayden Adams, who is actually the architect of Uniswap protocol. So this video will give you a brief understanding about how DEXs work in general, and you don't need any understanding of blockchain in order to proceed with this video. And we're not going to use any blockchain programming language like Solidity or SmartPy. I will be writing code in just Python. So the question is, what are DEXs, right? So DEX are basically decentralized exchanges where you can exchange one quantity of one asset into another, right? So for example, you have a asset called token 1, you can exchange it into token 2. Okay, so this is how the DEXs work and basically what DEXs are, right? So generally there can be multiple kind of DEXs. The one we're going to talk about uses CPMM algorithm, which is constant product market making algorithm. So which is X into Y is equals to K. So basically X and Y is the amount of tokens that are there in the pool. So pool is basically a place where we are storing the token, so which is going to be a smart contract. But for demonstration, let's say we have two tokens. First one is X, let's call it token 1, and then we have Y, which is token 2. And each of these tokens uses the decimals. So I'm going to give you guys the decimals here. So they uses 9 decimals. So why I am writing this, because generally in blockchain you don't have the decimal data type, so you need to work with the integers and numbers only. So that's why the amount of zeros is 9. So you can see if we multiply 9 times, we'll get 9 zeros. And so basically if you think about one token 1, it is going to be 1 into 10 raised to the power 9, right? Because this is the amount of zeros that needs to be there. Alright, so this is basically acting as a decimal to increase the efficiency. So basically let's consider a scenario when you initialize the pool, basically when the pool starts. So at that stage you have 100,000 amount of X tokens, so you need to do something like this, right? Or I should just use decimals. Alright, so you have this amount of X tokens, and in the same way you have Y amount of this much tokens. Let's say now someone came to our DEX, let's call her Alice, and she wants to exchange her 50 X tokens into Y tokens. So we need to find how many Y tokens she will get. So the idea behind CPMM is the product, the invariant needs to be constant. So in this case you can see the invariant needs to be constant. So earlier we have our invariant. So basically this is what invariant is. So invariant. So in this case the invariant was 100,000 into decimals, right? And we're going to multiply it by 2. Basically we need to find the square of it because we need to multiply it 2 times. So this is what invariant was, right? So now if you talk about it, so she will send 50 X tokens. So new amount of X tokens would be 100,000 into decimals and then plus 50, right? Because 50 is basically the amount of tokens that she is sending. So I can do something like this. Right, so basically this is going to be the new amount of X tokens, and you need to find the new amount of Y token, right? So in order to find the new amount of Y token, first of all you need to make sure that the invariant needs to be constant, right? So you can do something like new X into new Y. It always needs to be the same invariant. So in our case it is going to be this, right? Cool. So we need to find the new Y, so we will do something like this. So it is going to be the exact same number here and divided by the new X. right? So this is actually going to be the formula in order to identify the new value of Y tokens in our pool. Okay, so this is the new value of Y tokens, but how much she should get? In order to find that, you actually need to, let's call that out, and you actually need to subtract the old amount of Y token, which was Y, or I can just use this. Now, one thing to note here is you need to understand that previously we have had 100,000 tokens, but as the amount of X token increases and we want to give Y tokens, the amount of Y token would be less than this, right? So we're going to multiply it, subtract it by the new Y tokens. So this is going to give you the amount of Y tokens that you should that she should get. All right. So this is how the simple DEX work. And if you go over to the create exchange thing, so this is the create exchange will allow you to create a new exchange, which is basically creating a new pool with two different pairs. So this is actually done by making something called a factory contract that keep tracks of all the new tokens that are generated, or all the new token pool that are generated. And in Ethereum, you can use something like this, although I am not really familiar with Ethereum, but in SmartPy or in Tezos ecosystem, you have a similar way of creating a new contract using the object. So, consider this a specific thing, ETH to ERC20 trades. So ETH is basically the native Ethereum currency here, and ERC20 is basically the fungible tokens. So in this specific demonstration, they have also introduced this term called fee. So you can see that they are actually dividing the amount of tokens that the person is sending divided by 500, because they are also introducing the fee. But in our demonstration, we don't have any fee, right? So then what they are doing, you can see they're setting the invariant. So this is the old invariant, and then they're calculating the new amount of ETH tokens, which would be the old ETH value plus the amount of ETH value that you are sending. And now in the same sense, they can find the new token pool, which is essentially, in our case, it is going to be new Y. And you can see they are dividing invariant by the new ETH pool, right? But instead of dividing it by the new ETH pool, they are doing something like new ETH pool minus fee, because they want the fee as well, right? They want to reserve fee for the admin. So this is why they're doing this. Cool. So let's code this specific portion, whatever I've discussed, and we can move further. All right. So I think I can just copy some of the information from the comments itself. So we have decimals as this much amount of decimals. Let's just set the interpreter as well. User bin Python 3. Perfect. So we have decimals as this. The amount of X tokens is essentially 100,000. So 100,000 divided by decimals. In the same way, the amount of Y tokens is also 100,000 divided by decimals. Alright, so this is essentially the X and Y amount of decimals. And then we are going to set the invariant here. So we'll do invariant. Invariant. And obviously it's an integer. So invariant is essentially X into Y. In the same sense, I can also define the type of these numbers. Cool. Perfect. Now let's talk about, let's create a method that will exchange X into Y. So we'll do X to Y as the name of the method, and it takes the X amount as the argument, which is integer, and we give back integers as well. All right. So this method, it converts X into Y. Perfect. So the way we calculate it is by actually doing something like this, new X. So new amount of X tokens would be the old amount of X tokens plus the amount of tokens that we will get. So X underscore amount, right? And in the same way, new amount of Y tokens would be the invariant or I can just I have actually explained you why we are doing the divide, because you need to make sure the invariant is constant. So this is the equation that needs to hold true, right? New x into new y, it needs to be the old invariant. Okay, so you can see that new amount of y token is actually inversely proportional to x tokens, which means as the amount of x token rises, the amount of y token decreases, right? So in this specific scenario where she was sending 50 tokens of x, she would then the amount of x tokens is increasing, which means the amount of y tokens will decrease. Alright, so the new amount of y tokens would be the invariant, which is a global variable here, and make sure we are doing the this division so that we don't get the decimals. So this is integer division, and now we're going to divide it by the new amount of x tokens. And make sure another thing to note here is we are not using the concept of fee, but I will soon introduce it as well. So this is now going to be the new amount of y tokens that needs to be in the pool. So we are first of all going to calculate the out tokens, which is basically the amount of tokens that she will get. So out tokens is actually going to be the subtract, so basically the difference between the old y tokens and the new y tokens, because we know the amount of y tokens is decreasing, right? And then we're going to return the out tokens. Right, so this is pretty simple and easy to explain. So I will give you this here. So Alice exchange 50x tokens into y. So I'll just write it. Cool. So we're going to print y tokens she will get. So the amount of tokens that she will get would be, we can get it by calling x to y, and here we will provide the value of x tokens, so basically 50, but you also need to provide the decimals, right? Because over here if you see this x amount here, it needs to have decimals because the capital X has decimals, and otherwise it will mess up the calculation. Then the new x amount will also have the decimals. In the same way the new y amount will have decimals, and in the same way out tokens will have decimals. Perfect. So this is actually going to be the amount of tokens that she will get. Let's run it. So we will do something like this, python and /main.py, and you can see this is what we are getting. Now you might think this is a really large number, and it is primarily because of decimals. So what I can do here is to create a variable out tokens and do this, and we can do out tokens divided by 10 raised to the power 9, right? And why are we getting why am I doing this? Because of the decimals. This amount of the token that you are getting, it includes the decimal. So if I run it again, you can see that she will get 49.97 amount of y tokens. So this is how a simple DEX works. Now let's make it a bit complicated by introducing the first of all, one thing that I forget here is we are doing this, which is calculating the out tokens. We also need to update the amount of x tokens that we have. So in order to do it, first of all, we need to declare global variable by using this. So global x, global y, and in the same sense we have global invariant. So let's update them. So x needs to be equals to new x. In the same sense, y needs to be equals to new y. And in the same way, invariant needs to be equals to x multiplied by, right? Because basically new x into new y. Cool. So this is how it works. Now if I run it, we would expect the same result, but if I copy it again and paste it here, now I'm going to change the name to Bob. Let's say Bob. Alright, so the other person is Bob. Now if I run it, you will see that when Alice came, she wants to exchange 50 X tokens into Y tokens. So the amount of Y tokens she get was 49.97. But when other person Bob came, he also exchanged his 50 X tokens into Y. But at this case, if you look at it closely, the value are decreasing. So it is 49.925 instead of 49.975. And can you guess why? Well, the answer is because the supply, or the amount of Y tokens in our pool is decreasing, right? Because let me do this. So I'm going to print the X here. Let's use F string, so we'll do F and then X, and in the same sense we will do Y as Y. And we also want to make sure that we consider the decimals, so we're going to divide it by decimals, and in the same sense we're going to divide it by decimals. Perfect. Now you can see, let's just copy it here and paste it here. Fine. And also one more thing, we should also copy and paste here. Perfect. Let's understand now. So initially you can see the amount of X and Y tokens was 100,000. When Alice wants to exchange 50 X tokens, she get 49.95 tokens. Now after doing this, the new amount of X tokens was 100,050, and new amount of Y tokens was 9,999. It is 1 times 100, 1,000, 10,000. Okay, 99,950 point something. Cool. So now you can see that the amount of X tokens increases and the Y tokens decreases. So now if somebody else came and he or she wants to exchange the same X tokens into Y, they will need to pay a much higher amount of X tokens in order to get same amount of Y tokens. Why? Because the supply of Y is decreasing, and as I have mentioned earlier, that the new amount of Y tokens is actually inversely proportional to the amount of X tokens. So if the X amount of tokens increases, the amount of Y tokens would decrease, right? So this is how it happens. So in the same sense, if somebody else is going to come again and wants to exchange 50 X tokens, he will get much less price. Let's do it again. So what I'm going to do is copy this Alice case, and let's say she wants to exchange again. So now you can see that initially it was this, then this, and this. You can see the amount of Y tokens is decreasing, and the tokens that they are getting initially was 49.97, then 49.92, and now it is 49.87. So now you might ask that if we have two different assets in a specific pool, and if somebody start exchanging their tokens, then it would disrupt the pool, right? And people will get wrong amount of tokens. Well, you're correct, but at the same time you also need to understand two things, that in DEX we have two different things as well. The first thing is arbitrage. I hope I am pronouncing it correctly. Let me just verify. And the other thing is the market makers. So market makers are the people who make sure the price remains same. So basically what happens is, in the crypto market, we have the concept of market makers who control or govern the price of the tokens in a specific pool. So basically you can see in this specific scenario that our amount of Y tokens are actually decreasing. So what market makers would do, they will actually increase the amount of Y tokens by investing some amount of liquidity in the token. So investing liquidity basically means adding more tokens to the pool. And the other situation is, okay, it is arbitrage. So RAGE. The other situation is arbitrage, which is actually a situation where at two different pools or two different exchanges, you might get a different amount of results, right? So for example, in this specific exchange, let's call it exchange A, when you want to exchange 50 tokens of X, you are getting, let's say, 49 tokens. And in some other exchange B, you want to exchange for 50 tokens of X, and there you are getting 52. Okay, although this value can vary depending upon the exchanges and the algorithm they use, but generally if you consider this scenario, then people will have the opportunity to buy things from this pool and sell here, right? So basically what they will do, they will buy the price at they will basically exchange their X tokens into Y at a larger price. So they will go to the pool B and they will do this, and then they will again go to the pool A, and now they will exchange their token Y into X back, so they will get more amount of X. So this is how this is one way of fixing this scenario, and the other way is the market makers, who are basically the people which governs the price by providing the liquidity, okay, or divesting the liquidity, investing or divesting the liquidity. So yeah, this is how the basic DEX work. In the same way, or in the same sense, you can exchange your Y amount of tokens into X amount of tokens, and you would get the same result, right? Now, in this specific white paper, they have actually mentioned one more thing, so which I need to cover. So for example, they are taking the scenario where they are exchanging the ERC20 tokens into Ethereum and Ethereum into ERC20 tokens. So the thing is, Ethereum is a native currency and ERC20 tokens can be multiple, right? So basically, if you want to exchange your ERC20 token into ERC20 token, right? At that stage, you first of all need to convert your ERC20 token into Ethereum, and then you need to convert your ERC20 token into another ERC20 token. So for example, this was X and this was Y. So first of all, you will convert your X tokens into Ethereum, and then you will convert your Ethereum into Y. So this is another step that you need to take in this specific white paper. So you actually need to pay double fee. Now you might ask why and how. So basically the thing is, when you will exchange your X amount of tokens into Ethereum, you actually need to pay 0.2% of fee, okay? And then when you exchange your Ethereum into Y tokens, at that stage again you need to pay 0.2% of fee. So this is why you actually need to pay double fee, and this was one of the drawbacks of the Uniswap V1, although they later introduced the token to token pool probably. But if you take a look at other DEXs like Curve Finance, they have the different algorithm. So basically the thing is, there are multiple ways of governing prices and creating DEXs. This was one of the simplest one, and Curve Finance is another way where the DEXs work. So if you go to the pools, you will get, so you can see these are the pools, and if I open any one of these, so this specific pool contains these 3 tokens and you can exchange any one of these, right? So this will give you much more better result. And also Curve Finance uses another algorithm which combines the constant product and constant sum. I don't want to go much deep into it, but if you want to know more about Curve, let me know and I will make a video on it. So yeah, this was it for this video. So we have actually talked about how Uniswap V1 works, and if you want more videos on white papers, let me know and I will start making. So yeah, bye.